Alrighty, back at it, 0.5 notes. We're doing some things here where we have a couple different sets of functions and we're doing different operations with the functions. On the back side of our notes here, we're actually going to talk about taking a look at both numerically and some with variables, throwing in some input here, and then can we do a little bit of math work with it, especially with the ones that have just the constants in it, because we can then evaluate it completely. So there is a little bit of math work to be done here. I know we don't have a huge amount of numbers in your spacing here, a huge amount of space here, but I'm going to try my best to help the cause. So for instance, my first one that I'm taking a look at is f plus g of 2. So what that means is that I'm going to add the two functions, but 2 is going to get the input for the f, and 2 is going to get the input for the g as well. So at the end of the day, what happens with that? Now, I did write it out just so we can take a look at it. There are a couple different ways to attack this. This is the way that I'm going to attack it. And I'll try to color coordinate. So I'm going to take that 2, I'm going to plug it into the f function. And so if we notice, I would take the 2 and plug it in. So 2 times 2 is 4. 4 minus 5 would actually be -1. So if I'm looking at this top set of problems, the f function, I take a 2, plug it in, I would get -1. I'm going to go ahead and add, and then g of 2, so take the number 2, plug it into the g function. It would be 2 minus 2, which is 0. So that result would be -1. Again, taking whatever that number is, plugging it into both functions, and then adding it together at the end. We'll keep on keeping on here. I have f minus g of 1. So again, the 1 is the input, not just the letter x, but the 1. So I'm going to take the f function, plug 1 in. I'll take the g function, plug 1 in. So f of 1, 2 times 1 is 2. 2 minus 5 is -3. Let's go ahead and be careful. We got a minus sign there. And then g of 1, so I'll take the g function, plug 1 in. 2 minus 1 is 1. -3 minus 1 would mean that I would be able to evaluate that down to -4. Again, I'm just taking the numbers, plugging it in. All right, then I'm going to multiply here. I got f times g of -2. And I'll take -2 and plug it in. So again, I'm saying all this math work out loud. If it confuses you, come with questions when we see each other next. But I'm going to plug -2 in here. So plug in -2 into the f function. 2 times -2 is -4. -4 minus 5 would be -9. I'm going to multiply that to whatever g of -2 is. 2 minus a -2, 2 minus a -2, that's a minus negative next to each other, so it makes a +2. 2 and 2 would make 4 here, and then I multiply that out, and I would get -36 for that. Last one's a weird one, not only because it's division and we didn't have a lot of things that we can do with it, at least currently in unit 0 here, but I see a variable, so I'm going to plug in x minus 1 wherever there was an x, which is kind of sort of weird to think about, but here's what it will look like, and I've saved this space for this specific reason here. So in the f function, which is on the top, the x is coming out, and x minus 1 is going in. And for the g function, x is coming out, and x minus 1 is going in. So just like all the other ones, we're just using it as an input. The difference here, of course, is that it's a variable, so we won't be able to clean it up completely. I did just notice I missed the -5 there, so sorry about that. All right, a little bit of distribution for the f function, 2x minus 2, and I got the -5. So for the f function on the top, if I had to clean up like terms, it looks like I have 2x minus 7. That's the linear function up there when I combine the constants. For the g function on the bottom in the denominator here, I got to distribute the -1. So it'd be a negative x, it would be a positive 1. And if I clean that up and put it in descending order, negative x plus 3. Again, I have these variables here. There's two terms. There's a binomial on the top. Right now, I'm not worried about reducing. We'll get there eventually. But since it's not all constants, that's the end of the problem. That's the best I can do. I'm wrapping it up right there. The procedure happens again down at the bottom. I'm just doing some more just to kind of check out some different appearances of things. I have a quadratic here for the function f on the bottom section on the notes. Again, though, it's f plus g of 2. So I got to take the two functions and then input 2. So for the green, f of 2 in this situation, 2 squared is 4. 4 plus 6 is 10. And then g of 2, oh, now this is weird. This is weird because now I have, underneath the square root, I have 1 minus 2, which is 1 minus 2 is -1. And for now, eventually in this class, there will be a lot more that we can do with that for now. But let's for now just leave it like that. Something I don't necessarily need to deal with. Next up, we'll go ahead and f minus g of 1. So f of 1, 1 squared is 1. 1 plus 6 is 7. Minus, oh, yeah, we're good. And then g of 1, well, if I take 1 and I plug it into the g function, square root of 1 minus 1 would be 0. Square root of 0 would just be 0. And that leaves me with a 7 for that. Fantastic. Moving right along, we're going to go ahead and multiply here. So I got f of -2. So -2 squared is actually 4, and 4 plus 6 is 10. So we have another 10 showing up here. And we have the multiplication of the two functions going on. G of -2, underneath the square root, I got 1 minus a -2. 1 minus a -2. So 1 minus -2 would be 1 plus 2. And so we would have the square root of 3. And again, for now, let's go ahead and just keep it as is there. So I have 10 square root of 3 as my final response for that. And then finally, and this is, again, something that's kind of sort of weird, so I'll show a little bit of my math work here. I got to take a variable set. So this could be like 2x, or it could be like 7z. We could do something random like that. Here it's x minus 1. So for the f function, replacing the x and putting in the input, like that right there. X minus 1 squared. Well, in case you're interested, I could rewrite that, right? Like that. And then distribute. I got x squared minus 1x minus 1x plus 1. So for just the f function itself, I have x squared minus 2x plus 1, and I still have to add that 6 right there also. So at the end of the day, the f function here, x squared minus 2x, and then be careful with the constants. I have a plus 1. I'm going to add 6 to it because the 6 is on the back end of the function. That's going to be a positive 7 on the top. And then again, it's going to look even weirder on the bottom here. When we plug it in, the x is coming out. The x minus 1 is the input here. And it's going behind a minus sign, so be careful. distribute that negative, combine like terms, and I have this right here, square root of negative x plus 2. And I did a little bit of cleaning up on this, but we'll just leave it like that because it's a variable and there's nothing to actually solve for as it is, or simplify. So we got x squared minus 2x plus 7 on the numerator, and then on the denominator we have square root of negative x plus 2. So again, the big takeaways on the back side here is paying attention to what the input is and then doing the operations with the different functions.